Hello and a very warm welcome to Cognito Key. Today, we're going to uncover the secret of a tiny, unsung hero inside our bodies, an enzyme called diastase. It's this hidden powerhouse that decides how we get energy from some of our absolute favorite foods. And, it might just be the answer to why you sometimes feel bloated after a big pasta dinner.
You know exactly what I'm talking about, right? After a lovely meal of rice or potatoes or bread, you can sometimes feel a bit heavy, bloated, and just, well, not so great. It's something pretty much everyone has experienced, and it turns out the reason is hidden deep inside the very structure of these foods.
So in this explainer, we'll kick things off by looking at what we're calling the starch problem. Then we'll introduce you to our digestive hero, diastase, and we'll even see it in action in a really clever experiment. We'll also take a peek at its personal rulebook, the conditions it needs to work best, before we tie it all back to how this tiny enzyme makes a big difference in our everyday health. All right, let's get right to the heart of the issue. The real culprit behind that uncomfortable feeling after a meal is a molecule called starch. It's a type of complex carbohydrate, and it's found in so many of the foods we love to eat. I want you to think of starch as a long, beautiful necklace made of pearls. Now, each one of those pearls is a little unit of energy, but our body can't actually use that energy when it's all strung together in a chain. We need some kind of special tool to break that necklace apart into individual pearls or simple sugars that our cells can finally absorb and use for fuel.
And that special tool? Well, that is nature's perfect solution to the starch problem. And it's the star of our show today, the diastase enzyme.
So diastase basically works like a tiny pair of molecular scissors. Its one and only job is to find those long starch chains and just snip them into a much simpler sugar called maltose. Now, you might have heard of a similar enzyme called amylase. That's the one in our saliva that actually starts this whole process the second we begin chewing our food.
And hey, this isn't some brand new discovery. Scientists first found diastase way back in 1833 in a malt infusion. And today, we know it's found in all sorts of natural places, from germinating barley seeds and other plants to yummy honey and even milk.
Okay, so talking about how it works is one thing, but what if we could actually see it working? Well, it turns out scientists have a really clever and visual experiment that proves diastase is on the job. Let me walk you through it. First, they take a petri dish and fill it with a special gel that's packed with starch. Then, they place some germinated barley seeds, which, as we know, are full of diastase, right on top of that gel. After letting it sit for a while, they pour an iodine solution over the whole thing. Now, iodine has this really cool property. It turns dark blue or black whenever it touches starch. And the result is just brilliant. You see this clear golden circle, a halo around each of the seeds. Why? Because the diastase enzyme literally leaked out of the seeds and broke down all the starch in that area. No starch means no dark color from the iodine. But check this out. If you do the same thing with boiled seeds, the whole dish turns dark. The heat completely destroyed the enzyme, so the starch is still there. It's amazing, direct, visual proof that diastase is hard at work. Now, just like any specialized tool, or even a superhero, diastase doesn't just work anytime, anywhere. Oh no, it has a very specific set of rules, its own little operating manual, for when it performs at its absolute best.
One of the most fascinating things is its sensitivity to pH levels. Diastase really loves a neutral environment, performing at its peak at a pH of around 6 to 7. If things get too acidic or too alkaline, its activity level drops off a lot.
Temperature is also super important. Diastase works best at a temperature that's very close to our own body temperature, right around 35 to 40 degrees Celsius. But it's also thermolabile, which is just a fancy scientific word for being really sensitive to heat. If you boil it, its delicate structure gets completely wrecked and it just stops working altogether.
So let's do a quick recap of its superhero stats. It needs a neutral pH and body-like temperatures to work its magic. It can't stand high heat, and we can find it naturally in sources like malt extract, honey, and those barley seeds we saw in the experiment.
Okay, so that's the science. We've seen what it is and how it works. But now for the big question. Why does any of this really matter to us in our everyday lives? Let's bring it all back home.
While the biggest and most direct benefit is actually quite simple. Diastase helps our bodies properly digest all that starch. It takes those complex carbs in our grains and potatoes and quickly turns them into simple energy that we can actually use. So not only does it help prevent that heavy, bloated feeling, but it also makes sure we're getting all the fuel we possibly can from our food.
And this becomes even more important as we grow older. You see, our body's natural production of digestive enzymes, including diastase, can start to decrease over time. And this can lead to problems like indigestion and bloating, which is why having access to diastase can be so helpful for so many people.
Because it's so good at what it does, diastase is used all over the place. You'll find it as a key ingredient in digestive aid supplements, of course, but it goes way beyond that. It's a huge player in the brewing industry, for example, where it breaks down starches and grains to make sugar for fermentation. And it's even used in food production to create pre-digested foods that are gentler on the stomach.
So, the next time you're enjoying a meal with potatoes or a fresh piece of bread, maybe you'll give a little thank you to this tiny, hardworking enzyme. And it really makes you wonder, doesn't it? What other amazing little helpers are hidden away in the food we eat every single day, just waiting for us to discover them?
That's all the time we have for today. If you enjoyed this little journey into the world of diastase, please do give this explainer a like, share it with someone you think might find it interesting, and of course, make sure you subscribe to Cognito Key for more deep dives into the amazing science that's all around us. Thanks so much for watching.